Make yourself indispensable at work, build cool projects at home, and automate repetitive tasks with the Python programming language. My name is Matthew Pagan. I've been programming for the last 15 years, and I want to show you how you can become a master Python programmer. If you're at the command prompt on your computer, open the Python shell by typing the word Python. Download it from python.org whether you're on Mac, Linux, or Windows, and open it by typing the word Python at a command prompt on your computer. You've just opened the Python command shell, also called the Python interpreter. To close it out, type the word exit, followed by open parentheses and close parentheses. Let's do that one more time. Let's start off with the basics. You can use Python as a general purpose calculator. Start by typing some numbers. These two numbers are both integers. You probably know that an integer is any whole number, whether positive or negative. All the basic numeric operations you would do with a calculator on your smartphone or on your laptop, you can do with Python. Whether that's subtraction or addition. Multiplication is there as well, as is division. When we do division, though, the output is no longer an integer, but a float. We'll talk about floats in the next lesson. To do exponentiation in Python, use 2 asterisks. It's a pretty big number. One advantage of using Python over a normal calculator is that Python can handle huge numbers. How big was that number? Python makes it easy to keep track of how big your numbers are. You can clump together groups of 3 digits with the underscore. In the United States, we normally do this with a comma, and in Europe, it's commonly done with a period. Here's how it looks in Python. That's 1,000. That's a million. That's a billion, and you can keep going. This is of course optional because the Python interpreter strips out those underscores and treats it like a normal number. The output is still an integer. The 3 types of numbers in Python are integers, floats, and complex numbers. But for this lesson, we're just going to be talking about integers. Some programming languages have limits to the size of the integers they can hold. This limitation exists in Python as well, but in practice, you can't reach it. Here is the largest possible integer that Python can store. 2 to the power of 276 quintillion, 701 quadrillion, 161 trillion, 105 billion, 643 million, 274,000, 210. Minus 1. This number is a valid integer in Python, but it would take so long for the Python interpreter to complete this operation that you would run out of memory. That's why the operation was killed. And just because you can store numeric values up to essentially arbitrary sizes in a Python int doesn't mean you'll be able to print that value to your terminal screen or to a file like a log file. Let's look at another really big integer. 10 to the power of 4,300 -1. Oops, looks like the shell killed our Python interpreter, so we'll open it again. Now let's rerun that mathematical operation in Python. Again, we'll subtract 1. There are 4,299 nines in this output. It's the biggest number Python print. So let's do that one more time, but this time we won't remove the 1. Python can store this number in memory just fine, but it can't print it to the screen. That's why we got an error saying that this number exceeds the limit for integer conversion. Even though Python only lets you print numbers up to 4,299 digits long, the integer data type can store numbers longer than 83 quintillion digits in memory. It just can't print them. In Python, integers called ints can get huge. For all practical purposes, Python's int data type has unlimited capacity. So let's take another look at that number that wouldn't print to the screen. 10 to the power of 4,300. In fact, let's make it a little bigger, 4,301. Now we know that if we run this command, we'll get the same crash, a value error. But let's do something different this time. We'll use a Python built-in command type. The reason we got back int is because the number is an integer and because Python was able to calculate it just fine. It just can't print it. This built-in command type shows you what the numeric type of any number you're working with is. So let's go back to some basic addition. If we take 3 plus 6, we can expect to get a 9, but let's look at its type. Using the type built in, we'll look at the type of the output instead of the content. As expected, we got back an int. We'll talk more about floats in the next lesson, but a float is a number with a decimal point, a fractional number, or a number written in scientific notation. Let's take it as an example 6.0. That's a float, and we can confirm this with the type built in. Sure is, but what happens when we add together an int and a float? Some programming languages can't handle the interoperation of two different numeric types, but Python can. The output of an int plus a float is always a float. And we can confirm this with the type built in once again. As expected, we got back a float. Another Python built in is the command int. It can convert numbers into integers. We already know that when we add the integer 3 and the integer 6, we'll get back the integer 9. So if we convert this operation to an int, it doesn't do anything. We still get back the integer 9. But what about that operation where we added together an integer and a float? We know that an int plus a float makes a float, so we can cast the output of that operation back to an int with the int built in. The integer 3 plus the float 6 produces the integer 9 when the operation is wrapped around the int built in. Because of Python's flexible type system, you can add integers to the values true or false. an int type plus a bool type, which is what true and false are, produces an int. In mathematical operations with numerics, true has the value of 1 and false has the value of 0. Oops, we misspelled the word false, which Python was expecting to be uppercased, kind of like how true looked. So let's do that again. There we go. 3 plus false is 3 in Python. So what was this int built in? Well, let's use another built-in to check it out. The type built-in says that int is a type. And when you call int with no arguments, it produces the integer 0. And we can confirm that that 5 really is an integer with the type command. But we can also see that the output doesn't have a period, doesn't end with .0, and that's a good indicator that it's an integer. But in more complex programs, you may want to use the type command just to be sure. Now let me show you one last Python built-in you can use to confirm the type of any object, like a number. It's called isInstance, no spaces. Which you can use to check whether the output of any operation is an integer. Let's say we're multiplying the number 90 by 8. We'll put 90 times 8 in there, and then a comma, and then the type int, and then we'll close out the parentheses. It says true. 90 times 8 sure is an int. When we got that true back, it means that 90 times 8 is an int. We'll discuss some other handy uses for the int built in after we discuss strings. But for now, just understand that int is one of Python's 3 numeric types, along with the float and the complex, and we'll be talking about the float in the next video. If you want to try out the code from this video yourself, I've uploaded it to GitHub. There's a link to it in the description to this video.